Now, what on earth is sterilization? Well, imagine you want something to be super clean, cleaner than clean. Sterilization is how we do it. It's all about getting rid of tiny living things called microbes or germs. These little guys are everywhere, on your hands, in the air, and even in some food. Many are harmless, but some can make us quite poorly. So sterilization is our scientific way to make sure there are no living microbes left that could cause trouble. It's a really important process in many parts of our lives, helping to keep us all safe and sound. This super cleaning process is vital in lots of places. Think about hospitals. Doctors and nurses use special tools for operations and checkups. These tools must be completely sterile. If they weren't, nasty germs could get into a patient and cause a serious infection. That would be terrible. Then there's the food we eat. Sterilization helps keep our canned foods like beans and soup safe to eat for a long time. It stops them from spoiling. And in science labs, when people are making medicines, everything needs to be incredibly sterile to make sure the medicines are pure and work properly. So how do scientists measure how good their sterilization is? One way is with something called the D value. It sounds a bit like a secret agent's code name, doesn't it? The D actually stands for decimal reduction time. That's a bit of a mouthful. It simply means the amount of time it takes at a very specific temperature to destroy 90% of a particular type of microbe. So, if you started with 100 microbes, the D value is the time it takes to get that number down to just 10. It's a measure of how tough those microbes are. Let's try an example, shall we? Imagine we have some pesky bacteria, let's call them, and let's say we are heating them at 121 degrees Celsius. If the D value for at 121 degrees Celsius is 2 minutes, it means every 2 minutes at that temperature, we get rid of 90% of them. So if we start with 1,000 of these bacteria, after 2 minutes, only 100 are left. Wait another 2 minutes, that's 4 minutes total, and we're down to just 10. Another 2 minutes, 6 minutes total. And poof, only one is left. Science is amazing, isn't it? It is amazing. Now, we know temperature is a big deal in sterilization. Think about it. If you want to cook your dinner faster, you turn up the heat, right? It's similar with microbes. Higher temperatures usually mean we can zap those germs much quicker. But how much quicker? That's where another cool science term comes in, the Z value. The Z value tells us how much we need to change the temperature to make the D value change by 10 times. So it shows how sensitive a microbe's D value is to changes in heating or cooling. Pretty neat, huh? So the Z value links temperature and the D value together. If we increase the temperature by the Z value amount, the D value becomes 10 times smaller. That means it takes 10 times less time to kill 90% of the microbes. Wow. Conversely, if we decrease the temperature by the Z value amount, the D value becomes 10 times bigger. This means it would take 10 times longer to achieve the same level of germ-killing power. Understanding this relationship is super important for designing effective sterilization processes, especially if you can't use very high temperatures for some delicate products. Let's go back to our example. We said its D value was 2 minutes at 121 degrees Celsius. Now let's say the Z value for these bacteria is 10 degrees Celsius. This tells us something very useful. If we increase the sterilization temperature by 10 degrees Celsius, from 121 degrees Celsius to 131 degrees Celsius, the D value will become 10 times smaller. So at 131 degrees Celsius, the D value would only be 0.2 minutes. That's 2 minutes divided by 10. That's super fast. But if we lowered the temperature by 10 degrees Celsius to 111 degrees Celsius, the D value would become 20 minutes, 2 minutes multiplied by 10. Knowing the Z value is like having a secret power-up for sterilization. It helps scientists and engineers to be flexible. If they need to sterilize something really quickly, they can use the Z value to figure out how much to increase the temperature. Or if they have a product that might be damaged by very high heat, like some medicines or foods, they can use the Z value. It helps them calculate how much longer the sterilization process will take at a lower, safer temperature, while still being absolutely sure all the harmful germs are zapped. It's all about smart science. All right, science fans, let's explore another key idea in sterilization, the FO value. You might hear it called F0 or F0. This FO value is a bit like a score for the total killing power of a heat sterilization process. Specifically, it's used for steam sterilization, like in a machine called an autoclave. It tells us the equivalent time in minutes that the process would take if it was all done constantly at a reference temperature of 121 degrees Celsius. So even if the temperature inside the autoclave wiggles up and down a bit, the FU value adds up all that germ-killing power. The FO value is super handy because it gives us a standard way to measure and compare different sterilization cycles. The reference temperature is almost always 121 degrees Celsius, and it usually uses a standard Z value of 10 degrees Celsius because this is typical for many of the toughest bacterial spores we need to eliminate. For example, if a sterilization cycle has an FO value of 15 minutes, it means that the process delivered the same amount of microbial killing as if the items were held exactly at 121 degrees Celsius for a full 15 minutes. It's like a universal yardstick for sterilization. Now, why is this FEO value so important, especially for things like autoclaves? Autoclaves are these amazing machines, a bit like super strong pressure cookers. Hospitals, labs and food companies use them all the time to sterilize equipment, media or products. But we need to be absolutely sure they are doing their job perfectly every single time. That's where F value helps with something called validation. By placing temperature sensors inside the autoclave during a cycle, scientists can calculate the FU value achieved. If it meets the required target, they know the sterilization was successful. Safety first. Think of it like baking a delicious cake. You need the oven to be at the correct temperature for the right amount of time to bake it perfectly. The FEW value does a similar job for sterilization. It helps ensure that every batch of medical supplies, every can of food, or every vial of medicine gets the exact same effective dose of sterilizing heat. This consistency is absolutely vital. It means we can trust that our surgical tools are safe, our canned peaches won't make us ill, and our medicines are pure. Understanding FO helps keep everyone healthy. Let's imagine a real-world mission for our sterilization superstars: D value, Z value, and FEO value. Picture a company making a very important medicine. This medicine needs to be injected, so it absolutely must be sterile. They know that the toughest microbe they might find in their manufacturing process has a D value of 1 minute at 121 degrees Celsius, and its Z value is 10 degrees Celsius. The company wants to be incredibly sure the medicine is safe. They aim for what's called a sterility assurance level of 1 in a million. This means only a 1 in a million chance of a single microbe surviving in a vial. To achieve this super high level of safety, they need to reduce the microbial population by an enormous amount. A 12-log reduction, in fact. That means if you started with 1 trillion microbes, that's a 1 with 12 zeros after it, you'd want to end up with less than 1. So how long do they need to sterilize for at 121 degrees Celsius? They need to expose the medicine to heat for 12 times the D value, so that's 12 multiplied by 1 minute, which equals 12 minutes. This means their target FEO value for the autoclave cycle must be at least 12 minutes. This calculation is critical. Now, what if their autoclave doesn't hold exactly 121 degrees Celsius for the whole time? What if it runs a little hotter during some parts of the cycle, say at 124 degrees Celsius for a few minutes? This is where the Z value, which we said was 10 degrees Celsius, and the FEO calculation become really clever. The FO value doesn't just count the minutes, it calculates the equivalent minutes at 121 degrees Celsius. Time at temperatures above 121 degrees Celsius will contribute more killing power to the FO value, and time below 121 degrees Celsius will contribute less. The Z value helps to correctly weigh these contributions. It ensures the total germ-killing effect is accurately measured. So you can see how these three values work together like a team. The D value tells us how resistant the microbes are at a specific temperature. The Z value tells us how that resistance changes if the temperature goes up or down, and the FEO value gives us the overall sterilizing punch of the entire heat treatment, standardized to 121 degrees Celsius. Understanding these parameters, D, Z, and FO, is absolutely essential for the food industry, for making safe medicines, and for keeping medical equipment sterile. They are the guardians of safety, making sure our products are free from nasty, harmful microbes. Science is definitely cool,